This lesson will give you an overview of the utilities found in the Lattices tab. Watch as we walk through this example file and see how the different utilities affect our lattice. To retain this file as a resource, feel free to download it below. Opening the notebook outline to see the overview of our work, we've created a section for each of our utilities. We've begun by importing this CAD part of this shoe sole. We've created a CAD variable and converted to an implicit. We'll keep these both in our geometry section, along with a simple rectangular cell map, a unit cell, and a periodic lattice block. Let's begin by taking a look at the trim cell map block. When working with any of these lattice utilities, you see that our output type will be purple, denoting that they'll retain lattice properties. Let's isolate the visibility of our rectangular cell map and compare it with our trimmed cell map. Here, we see that we've used our implicit midsole as our trimming body and set our fill type so that any of the cells in our initial cell map that were touching our implicit midsole are retained. Now, when we use this trimmed cell map as our cell map in a periodic lattice, we see this result that more closely resembles our initial body. In addition to trimming our cell map, we can also trim a lattice itself. Here, we're using the trim lattice block to trim our initial periodic lattice. Our body will again be our implicit midsole. So if I isolate this trimmed lattice, we see that we've trimmed our lattice to that body. Notice that our properties match the properties of a lattice, whereas if we had used a Boolean intersect to achieve the same look, our properties are those of an implicit body rather than a lattice. The Modify Lattice Thickness block will take your input lattice and modify the beam thickness. Here, we're using our trimmed lattice as our input, and we can alter the thickness. Notice that even as we thicken our beams, we maintain the same outer surface as our trimmed lattice, and don't go beyond the bounds of the implicit body used to trim it. The Merge Lattices block will merge a list of 2 or more lattices. Here, we've taken our CAD face list from the outer part of the midsole, stitched it, and created a mesh from our CAD body. We used that mesh in a lattice from surface mesh block, where we chose our mesh boundaries and created the resulting lattice along those boundaries. We then used the Merge Lattices block to merge our trimmed lattice with that outer boundary. We can apply a thickness here as well, and the resulting lattice will have beams that all match that thickness. The Extrude Lattice option can help you to create ribs rather than cylindrical beams. If I move back up into our geometry section, I'll isolate our imported part and take a look at the bottom of this sole. We've selected our bottom face, meshed it, then remeshed the surface to have better control over our mesh element size. With this remeshed surface, we've again used the lattice from surface mesh block, now selecting mesh edges, and created the resulting lattice. We've then used the Extrude Lattice block, where we've used our implicit midsole as our direction. This indicates that our resulting lattice will extrude normal to the field of this implicit midsole. We've added a height of 2 millimeters and a lattice thickness of 0.5 millimeters. If I isolate, we see that we've created these ribs rather than those cylindrical beams. We've then converted the bottom of this sole to an implicit body and used a Boolean union to merge the two. Next, let's take a look at the Extend Open Lattice Beams block. This block will take any outer open lattice beams and extend them a user-defined distance. Insert a body in which you'd like to select those open beams, and those outer beams will be extended. To help visualize, I'll change our graph unit cell type to a simple cubic. Finally, the Collapse Lattice Vertices block will identify vertices that are within a certain distance of one another. Vertices falling within this distance threshold will be collapsed and merged with one another. With this distance threshold at 0 millimeters, you see open beams. And as I increase this distance threshold, we see some of these vertices start to collapse. One way to help visualize how this block works is to use this Delaunay lattice as our input. Because our vertices aren't spaced as evenly as they are in our body-centered cubic, we see how this distance threshold can affect our output. To reference this file later on, or further explore the lattice utilities, feel free to download this file below.